So basically, what we're going to do today is we will see some of the algebra problem which are like mainly based on sequences, and like throughout, like I see like if you encounter like such kind of problem, they are like kind of like one way, or like you got many ideas and like you can try to explore some of them. And it's not like every time you will use same idea, but ideas give intuition. Like you can get some new kind of intuition and how a different problem uh, involved. Okay, and I know like some of like algebra stuff happens like kind of bit details you have to fill up, but we will see how we can deal with it, and like how
Okay.
we like just do it basically. Okay, I hope everyone can see the problem.
This is a shortlist, right? I am a shortlist.
Yes, yes.
I think I have done it. Like Sai did it
Yeah,
in a magic problem set class.
the last
Wait,
problem was this.
we have wait like previous class.
No,
No,
the magic PSS one.
like quite a few days back. I mean, I think like
Okay,
1 2 months.
yeah, I can choose another problem. That's
Yeah.
fine. I guess it many of you have done it. Mm, okay, I will go with this one. This is also shortlist problem, but it's quite a good problem, so I would prefer to do this one. And if many of you have done like this one too, then I will give you some personal problem or something. How many of you have seen the solution or something? No,
I
right?
haven't seen it.
No, I haven't seen this.
Haven't. Okay, yeah. Yeah. Okay, so this is also very, yeah, okay, yeah. This is a bit interesting problem. So okay, so like let me explain the things. Like okay, so AIs are reals, and they are like they like repeat in like period of n. So like basically a of n plus I equal to AI, and we get this one like kind of interesting equation. We have to find for what kind of n this kind of sequence can exist. So any ideas, guys? Yeah, this geo looks weird. I agree. Okay. First hypothesis. Okay. Even wait. So first of all AIs cannot be constant, because like if all AI is equal to C, then C square plus one equal to C, and then wait.
I think
Why?
it's non-real roots or something.
Yes.
Yeah, non-real roots.
Yeah, and so that's why it cannot be. I guess it's imaginary roots. That's why it won't work. Yes.
Correct, correct. Imaginary non-real.
Then all AIs cannot be I. Like obviously I plus one. Like I don't understand what you mean by capital I. So this is also not true always. Mm, what else, guys?
Base cases?
Yeah. So what basically like
N equal to 3.
n equal to three. Okay. So you mean like okay. So a1 a2 plus one equal to a3, and a2 a3 plus one equal to a1. Yeah. And a3 a1 plus one equal to a2. So what do you think? How can like we proceed from here? I also saw like this one is. Let me see. Bound maybe. Like sequence is repeating itself. So like all like it doesn't kind of matter what's like how large can be numbers, right? So yeah. So what you get for like get from here? It's good.
So a1 squared minus a1 is equal to a2 squared minus a2 is equal to a3 squared minus a3.
Interesting.
Is equal to a1 into a2 into a3.
Okay, yeah, okay. You basically multiply this
Yeah,
by
by
3.
a3 and so.
Yes, which is equal to a1 into a2 into a3. Okay, like before, like wait, what happened? Okay, yeah. Before proceeding, okay, someone seen some pattern. Uh, 20. Okay, one more thing, I guess. Plus 1, 0. Yeah, it cannot have 0, I guess. Suppose a1 equal to 0, then you get like a3 equal to 1, and then okay, so the sequence you're claiming is like 1 minus 1 0. Let's see, will that work? Okay, interesting. Okay, this become plus 1, and then this become plus 2. This become plus 3, and this will increase. So this won't work. And similarly, I guess like if a2 is like positive number here, then a4 also becomes something like that, and it will also increase. So if you guys like observe what I did, suppose like uh, two numbers are positive, okay? So suppose ai is positive, ai plus 1 is positive. Then what we get is like
It
ai
will
plus
increase.
equal to ai into ai plus 1, so which is greater than 1, because like both of them are greater than 0. And because this is also positive now, we again get ai plus 3 equal to ai plus 1, uh, ai plus 2 plus 1, which is again greater than 1.
So you're saying the sequence will become unbounded after a while?
Yes, sequence will become unbounded at after some point, and which is not possible because it is repeating itself after n terms. So like what I'm saying, like both of them greater than 1, and because of that, yes, so because a1 is greater than 1, this is like less than equal to a1 plus ai plus 2, which is less than equal to plus 2. And okay, so the sequence is increasing, like ai plus 3 equal to ai plus 2, and so on. You will get same thing, which is not true. Yes. So that just basically means we cannot have like two consecutive numbers such that this is greater than 0, this is greater than 0. But also notice, like if you have two consecutive negative numbers, then that just imply like ai plus 2 is,
The same thing will happen, right?
no, it's greater than 0 now. Now it's not like it will decrease infinite times. This is like 1 plus ai. Okay, that's an interesting claim. So one person, like not one, sorry, the man claim that they have like alternative signs like this. Uh, okay, let's see. That's interesting.
Yeah, I couldn't get when both were positive in that case.
Okay.
Why was AI plus 1 times AI plus 2 is equals to AI plus 2? Like, I couldn't get how that works.
This is because of definition, right? AI plus 1 equal to AI plus 2. The definition.
Okay, got it.
Yeah. And similarly for AI plus 3, and both of them greater than 1. So this is greater than this, and this is greater than this. So we get this. And similarly for every. But like sequence repeat.
So if AI is less than 0 and AI plus 1 is less than 0, then AI plus 2 is greater than 1, I think.
Yeah. Yes.
Yeah, we will
Yeah.
have similar, right? Again, AI plus 2 is greater than 1 and then it will keep increasing. So that will be again contradiction, right?
No, because like we just have AI plus 2 greater than 1, not AI plus 1, right? We can have like AI plus 3
Okay,
equal.
but then like, okay, AI plus 3 will also be positive, I think. And then, oh, no,
No,
wait.
no, it need not.
Okay, it will be negative, right?
This is negative, but it may be positive, it may be negative. It's depend on like what's like value of this. And like if you not consider whole sequence, you can actually make it positive, negative, whatever you want. But wait, actually it has to be negative because if it's positive, you get consecutive positive numbers, which is not possible. Right.
Yes. Yeah.
Yes.
Okay, yeah, makes sense.
So
Then we
so
want it to be negative.
this is negative. That implies
That
Can
then
you
next
how
one
it
is
is negative?
positive, I think. And then like maybe the consecutive AI of different sign actually does hold.
now if like now claiming this is positive. Okay. Let's see how.
Can you repeat how it was negative?
See, if it's positive, then AI plus 3 and AI plus 2 both of them will be positive, which we prove should not be the case.
So we want an alternating signs sequence.
It will
Maybe.
not be like just alternating because we started with both negative.
Yeah.
So it is eventually
Like,
alternating.
I'm not claiming like we want alternative signs. You guys claim. I haven't said anything. I just said consecutive positive are not possible. That's
Yeah.
it. Also, anyone like okay now you guys get like this should contain one negative term, right? So there's one trick like rather than thinking some like higher like some obscure examples, can you just like come up with some simple example like just somehow which will work? Like suppose we consider a1 equal to minus 1, then what we get actually? We get plus 2 equal to a3 and okay, that's the same thing. Are you sure? This become minus 2. Uh, wait. See,
Okay, we
wait,
have
0.
2 minus 1 minus 1.
2 minus 1 minus 1.
Yes, and then it repeats.
So, okay, this will be minus 1, plus, no, minus 2 plus 1 minus 1. This will be plus 1, plus 1, 2. Then this become what? Minus
It'll
1.
repeat because minus 1 comma 2 is same as 2 comma minus 1.
Exactly.
Yes. So, or like, what can be the sequence? This can be the sequence, right?
Yes.
And this can like you can extend it however many times you want, and like until you get like minus 1 at the end, right?
Okay, so it's
Wait, multiples
all
of
of
3
them are the
was.
same mod 3. Exactly. Yes.
Yes, it's not same what I mean. Like it's not like you can always repeat, but actually like you get like in 3 divides n, then
Yes.
sequence 1. So everyone got it like how we get this thing. Like not 3 divides n, like n equal to 3k type sequence exists, which are like this. Like just consider this block and just repeat itself like infinitely many times.
Actually, like in the beginning, Nishant said a1 squared minus a1 equal to a2 squared minus a2. That holds for like not just like for this, then it wouldn't it imply like a1 plus a2 equal to 1 or like a1 equal to a2?
Wait, what do you mean? Like for this will become 2, right? And this wait, why it's not 1? Yeah,
Like
this
we
will
just
become 1 minus minus 1. Yeah.
yeah. So like uh I think like for other n also like n greater also we might be able to work something like similarly.
So the problem is like okay, suppose n equal to 4, you get like more sequence, right? It's not immediately repeat. Like
Oh, yeah. We get like
here
A3
is
into
it's just
A4. We have
3,
to
so
do.
like it's just triangle. Like for this you get this, for this you get this, something like that. But now
Yeah, and
we
yeah,
don't.
in 4 it doesn't make more sense.
Yeah, so after n greater than 4, it's not a symmetric group or something. It's just weird type things. Okay, but also interesting observation. This is less than 0, this is less than 0, this is greater than 0. Again, this is less than 0, this is less than 0.
Right, we don't have an alternating signs as of yet.
Yes, this does not have alternative sign. Okay, let's work on. So suppose like, okay, we consider from ai equal to like I equal to 1, not to like make it too weird. So suppose a1 less than 0, a2 less than 0. So what we get, a3 equal to 1 plus a1 a2. So both of them will be positive, so this will actually greater than 1. Okay, a4, a4 has to be less than, like, okay, a4 equal to 1 plus a2 plus a3, which has to be less than 0. Well, no consecutive positive numbers. And we know this is negative term because a3 positive, a2 negative. So this just imply,
So A2, A3 is less than -1.
yes, so a2, a3 less than -1. Now let's see. So what now we are like interesting about a5. So it can be positive, it can be negative.
I think
Now,
A2 is greater than -1.
Yes. Greater or less? No,
Greater
Less
greater.
than -1, right?
No, greater than -1.
Greater than.
I guess not greater than, I guess less than.
A3 is positive, so
Yeah,
it
A3 is
might.
positive, so it is less than -1.
Yes.
Acha, right.
Huh? Wait, A2, A3. Okay, sine theta, yes. Alright.
Why this is necessary because like a4 is less than 0. So like if you like put this my one to this side, you get.
Yeah, I flipped the signs, yes.
Yes. Okay, so let's see. So let's assume a5 is greater than 0. Okay. Either we will get contradiction or some kind of condition. Let's try to think for this, because like now you get it, like the problem is like now you get the feel of problem is telling you to like work on positive, negative, greater than 1, less than 1, and you get some kind of contradiction now. So suppose a5 is greater than 0, so a6 is less than 0, because you cannot have consecutive numbers. So what does this tell you? A5 equal to 1 plus a3, a4 greater than 0, a6 equal to 1 plus a4, a5 less than 0. This again imply a4, a5 less than -1. And this imply, because a4 is negative, yeah, what does that imply?
Wait, so A4 is less than -1 again?
It's greater than -1, right?
No, by A4, A5 less than -1.
Yes, because like a6 is less than 0, right?
So A4, A5 less than -1 means A4 is less than -1? No, no.
Yeah,
Yeah, like you're saying,
that is
because
only. No, A5 is positive.
positive.
And A3 is also positive. And if A3, A4 is greater than -1. Wait, what?
No, that doesn't help.
Yeah, that doesn't imply that. I'm confused why. Like even this, like I'm confused how you guys implied this. But if you look here, these two terms,
This is
will it,
implied because A3 is greater than 1, na? So if
Yeah,
A3
we
is greater
here
than 1,
only have greater than 0. In A3, we have greater than 1.
so A5 is only greater than 0. That's why we
So
can't.
what if we work with A5 greater than 1? Like then, okay, A5 greater than 1 is not possible from this, right?
from
No, why?
Yeah, because then in if for a5 less than -1, if
Oh, then
a5
be
was
greater
greater
than
than
0.
no, I'm saying that if greater than 1 is not possible. So it has to be between 1 and 0. Because if it was greater than 1, then a4 would be less than -1. And
Right,
from
yes.
a3 wala thing, we have a4 greater than -1, a contradiction. So
Wait, can you repeat? So if this is greater than 1, then you're saying this imply a4 less than -1.
yeah.
But that's just not possible because of this. Yes, that's wait. Someone claims. Yes, yes. Like you're saying same thing. Wait. What? Aryan, what we claim is like we cannot have two consecutive positive number because like then sequence will become infinitely increasing. That's why it's not possible. And so okay. So does everyone get this argument? Like, yeah, this is like correct argument. Yeah, if I remember. So like if a5 is greater than 1, then that implies like a4 is less than -1 because the multiplication is less than -1. Now, if this is the case, then you cannot have like a3 into a4 -1 because a3 is greater than 1. I don't know. Yes.
Yes, yeah.
So you will understand. So now a4, a5 is like less than 1.
In the argument, you said a3, a4 is greater than -1. We considered a3 is greater than 0. How you're commenting on a4 should be also be greater than less than
a3 is
1.
greater than 1.
A3 is greater than 1. And this is like less than like this is less than 0, that's clear. Wait, not less than 0. Yeah, this is greater than -1 because of this thing, right?
Wait, so a4 is greater than -1, less than 0, correct?
Wait, what? I could not hear.
A4 is
Yeah, I think that's correct.
A4 is greater than -1, less than 0.
From our previous bound also, right?
A4 is not less than.
A4 is greater than -1 because A3, A4 is greater than -1, I think.
Yeah, above we got a4 is less than 0, right?
Nee. Why this is so confusing?
Wait, let me just take my notes.
Om, can you scroll up a bit, please?
Yeah.
Yeah, I think it was written somewhere here. A4. Yeah, a4 is less than 0. It's written there.
Does make it.
So a4 is less than 0, but greater than -1.
Yeah, I think that's
This is true because of this, right?
Sorry?
Like a4 is greater than -1 because a3 into a4 is greater than -1.
Yes, yeah. Oh, that also, yes.
Yeah, but okay, now how we use it, I just forgot.
Wait, A3 is greater than 1 now.
Yes, yeah, a3 is greater than
So
1.
how does A4 greater than -1 follow?
No, we.
a3, a4 is greater than -1. No, that's right.
Oh, but we could also have equality. Perhaps we can show that.
Yeah.
But like,
Yeah, we should also have equality because 2 -1 has like equal to -1.
Right, so
wait, so
-1.
Oh, okay. Wait. Oh, yes. So what did I miss?
What?
Yes, this
How do we get that?
follows from both of these inequalities, right? Can you see? Like a4 into a5 is less than -1, a3 into a4 is greater than -1. So we get this.
A4 is
Oh,
greater
it
than
is
minus
-1 by
1.
a3, right? Like,
No,
Yes. A4 is
no, like because a3 and a5 are positive, you can just shift them there, right?
it won't
okay,
change.
so a4 is between -1 by a5 and -1 by a3.
Yeah.
Yeah, a3, not 1 by.
Acha, okay.
A3, yeah.
A3 is.
Yeah. So actually, like, okay, now you get this thing, right?
Can you again, sir, where you consider A3 should be greater than 1? Because
Because of this.
A2 you consider less than 0. A2, A3 less than -1. Then like A2 is less than 0, so A3 should be some kind of, if it is minus 0.1 something, then it will be positive. So A2, A3 will be greater than 0. So it will be in the right side of the -1 number line. So A3 should be greater than -1.
No,
A-
see, like we consider a1 less than 0, a2 less than 0.
Yes.
So the multiplication becomes positive and plus 1. So a3 should be greater than 1.
Oh, yeah. Sorry.
Yes. Then we consider a5 positive, a5 is positive. That gives us like a3, a4 greater than -1. Right? Yes. And then we consider like a6 should be less than 0. So this gives us this equation, which gives us like a4 into a5 less than -1. Now, what we do, we shift a4 like a3 to that side. So we get a4 is greater than -1 by a3. And we can do this because a3 is positive. We can do this also because a5 is positive. So we shift a5 down. So we get this equation. And that just implies this. And now you just like, what? Okay.
Wait, I think we have a contradiction.
Yes, yes, we have a contradiction. So this gives
Because yeah,
a3, this gives a3 is less than a5.
and A3 is anyway more than
Everyone,
1.
oh yeah. So everyone agree with this. But a5 equal to a3, a4. Right. So this is just not possible.
A4
Right.
is
I
negative.
did it like A3 is greater than 1, and we already know A5 is less than 1.
Yes, yeah, that's also. But yeah, that's also one of the ways you can. But okay, wait, let me just repeat the argument for everyone. Okay, sorry for confusion. So, okay, I'm just repeating the argument. We consider two consecutive less than 0. Okay, we get a1 less than 0, a2 less than 0. Wait, yes. So a2 less than a1 less than a2 is less than 0. So we get a3 greater than 1 because of things. Then because we cannot have two consecutive positive numbers, a4 should be less than 0. Right? Now let's assume a5 is greater than 0. Now you cannot have consecutive positive again, so a6 is less than 0. We get these two equations, less than and greater than less than, which give us like this and this. Okay. Now, if you shift like a3 downside, you get a4 greater than -1 by a3. And if you shift a5 this side, we get -1 by a5 greater than a4. Right? Which just imply this, and yeah, which imply this, which imply this. But now you have like a5 equal to 1 plus a4 plus a3 plus a4. And that's just not possible. Right? This a3, you can see like a3 plus 1 this is not possible because a3 is greater than 1. Yeah. If you consider,
Okay, so the contradiction is like,
yes, so contradiction is you cannot consider a5 greater than 0. So this just imply like a5 has to be less than 0.
okay, so we have a1 less than 0, a2 less than 0, a3 positive.
Yeah, so like you have such this kind of thing, negative, negative, positive, then negative, and now you cannot have positive, so you have to negative. Then
Okay,
again,
so we can we can repeat this argument.
yes, yes, and now like
So from
like,
this n must be divisible by 3.
yes, so this like follows like block thing, and like to get consecutive -n, you have to be the last thing positive, which imply like 3 divides.
Okay,
But
we have to
we are
find n,
assuming
or we have to find like ai also.
We found the sequence, right?
like in the question we have to find only n for which there exists ai, or we have to find ai also?
Yeah. So we have to find like n, like what
Oh
kind
yeah,
of-
okay, then we are done, right?
Yes,
So
we are
if
done.
only 3 divisible by 3 works, and it
Yes.
actually does work because we
Yeah.
showed an example.
Yes.
What
Wait,
if there's
how do we
zero or something?
Wait, what?
how do we show that alternating signs doesn't work?
See, so suppose you get like that's okay. So basically, like we wait.
We assumed that a1 is less than 0 and a2 is less than 0 from the beginning. We did not assume that we started with a negative positive or a positive
Yeah.
negative.
Okay, yeah, that's the correct point, and that have very interesting argument. But okay, let me just confirm. Everyone clear till now, right? What we did.
Last point I have a doubt how it is a contradiction. I couldn't get the equation.
Okay, so the contradiction is like we get a3 less than a5, but that's just not possible because a definition of a5 is this, and this is
But
not possible.
here a4 is negative, right?
Yes, a4 is negative.
So okay, got it. Okay, got it.
Yes, but yeah, like this equation implies like a3 less than 1 if you do the calculation, but
Yeah, okay,
that's not.
got it.
Yeah, so now the what we assume is like a5 is greater than 0. We did not assume anything else, so that's why this is contradiction, and that imply like a5 has to be less than 0 always, and that gives us like this kind of sequence. Now this everyone clear, right? I hope no one have any doubt or I confused.
Yeah, nothing.
Yes. Now there is one right catch zone put, and like I just like forgot to mention it, which is like actually very big issue. It's like okay, we just consider consecutive minus sign, but we haven't consider this one, like this a1 less than 0, a2 greater than 0, a3 less than 0, a4 greater than 0. So okay, so from this, let's assume we cannot have consecutive negative. If you have consecutive less than zeros, then we get like this sequence, like sequence should divide, n should divide 3, right? So let's assume we don't have consecutive this, and we just have alternative signs. So now let's just work out. So a3 equal to 1 plus a2 a1. Why am I handwriting so bad? Oh wait, did I miss something? Okay, yeah, let's do this. This is less than 0, and yeah, that just implies this thing. Then consider a4, which is greater than 0. This imply, I guess we do with something alternate. Yes, okay. Actually, like, okay, we have, because of this, what we get, this should be less than -1, right? No,
Greater than.
Greater than minus.
yes, greater than -1, so that this become positive. So now what can we get? Like, what contradiction can we get? Any idea? This also have like very nice concept. So
Okay, so a3 is greater than -1
a3 is greater than -1.
since a2 is positive, and
Either a1 or a2 is okay. Either a1 is less than
since a2
minus
a1
1.
is greater than -1, then a1 is also greater than -1, right?
No, it's a3 is greater than -1 upon a2. A2 is just greater than 0. We don't know anything else.
Yeah.
Yeah, it could be
A2
like
could be half, right?
Yeah, but we have a2, a1 is less than -1. So either one of them must be greater than 1 somehow.
No.
No, that's not implication. Like we can have both of them listed. Okay.
How both of them need to have like absolute
Saying
values
like this
than
is less
1.
than -1, right?
Yes.
Okay. So one of them is greater than -1. But like
Uh,
they're modulo, right? Like even a2 can have greater than 1, or a1 can have less than -1.
no, so the absolute value of both A2 and A1 must be greater than 1. Or greater than or
Not
equal.
both, not both. At least one of them.
At least one of them.
You can have like 5 and 1
Ah,
like
yes.
greater
Yeah.
than 2. Yes, right. Yes. Okay, so here like the idea here is like, I mean, it's not any big idea, but it's actually very, very useful always. So what we seen, like I will just shift, wait, let me just put how we, yeah. So A4 equal to 1 plus A2, A3 greater than 0, which is less than A2, A3, A1 equal to A3, right? Like 0, A4 greater than 0, less than A3. But
Yes.
now look at this. So now what we get is like 1 plus my handwriting is so bad.
A3
A2,
is greater
A1.
than A4.
This just imply like A2 is positive. So A3 is greater than A1. Right?
Yeah.
Yes. Now what we assume is like this is alternative all now, right? So like we get A5 is less than 0, A6 greater than
Just so
0.
A1, A3,
This is a
A5,
contradiction.
it
Yeah.
will keep on reducing in the model.
Oh yeah, okay,
Absolute
that's
values. The
very
absolute
nice.
values will
This
continue
will keep on
increasing.
It'll keep on increasing.
like all of them are less than 0, but like them said they will keep on increasing, which is not possible because we're going to repeat after some point.
Could we also just say like we have both the equations where we have in first equation we have A4 greater than A3 and then we say A3 is greater than A4.
Where we say like A3 is greater than A4, and it's not possible that A4 is positive, A3 is negative. Yeah, but so like what was the point is like, okay, both like we have like both of them positive, negative, so we just consider like their expansion and we get this equation A3 greater than A1, and then this will like continue unless we get two consecutive negative, but we prove like for two consecutive negatives we get this sequence. So does everyone understand? So like, okay,
But
so first idea was
A3 can't be greater than A4, right?
no, like A3 is less than 0. I'm saying this, right?
Yeah, so this is straight away contradiction, right? The statement A3 greater than A4 in the square bracket. Squares.
That's A1. That's A1,
That's
not
A1.
A4.
Oh, that's A1.
Okay. Okay, got it.
Yeah,
Sorry.
okay. Yes. Okay, everyone understand? Okay, let me just repeat the like,
It's like an infinite descent kind of idea.
yes. So let me repeat like all of the ideas in this question. So first of all, we try base case, and okay, while trying base case, we like try to you like understand 0. Like we always like consider 0 in the sequence, and then we get something like this is increasing. So we try to claim something like this. So what was our first claim is like this is not possible. Both of them cannot be consecutive greater than 0. And then we just prove it because because we get like all of them, both of them greater than 1, and so they are increasing and the sequence cannot increase. Okay, then this implies like we have so many negative terms, but negative into negative positive. So we have negative and positive terms. Then for n equal to 3, we try to like understand what can be the solutions. And like this is like kind of try and error, like you try -1, 2 or some base cases, or maybe 1.5 for some problems, and you get like this sequence, right? And this just like give us more about like n equal to 3k should work, right? Then like this give us understanding like we just have to work on less than 0 or greater than 0 or less than 1 minus 1, and now then we consider this thing. So we consider consecutive -1, and then we assume like a5 is greater than 0, but that just not true because of some algebraic manipulation, which is like this implies this and that implies this. So this both imply a3 is less than a5, but a5 definition is this, but and a3 is greater than 1. So this gives us contradiction, and because of this contradiction we should have a5 less than 0, and that's why we should have this kind of sequence. -1 plus 1 -1 like minus plus minus plus. So 3 divided sign. And there's one more case which is like alternative plus minus plus minus plus minus. But there we like use like, so we have like a3 less than 0 greater than a4, like a4 is greater than 0, and then we just like put the definition of both of them like this, and that just give us like a1 is less than a3. But once you have like something common, then this you can just repeat it infinitely many times, and this is not possible because you repeat. So everyone get the idea, right? It's like try base cases, try smaller numbers, then like you have to get feeling like this problem gives feeling like we have to work positive, negative, plus one, minus one. Then you just try to work on like some kind of contradiction related to that, right?
Yeah,
Okay.
that makes sense.
Yes. Okay, we
So we can do the same thing for if A1 is positive and A2 is negative. The,
A1 is
the
positive.
same argument we did for
Yes.
We need for
Yes.
negative positive, we can repeat for positive negative like that.
yes,
Well, it's
just change
cyclic
it.
anyway, the sequence.
Yes. Okay. Now, okay, let me see how many of you guys done this. Probably so many of you done, but still I will ask. There is one more question. How did I have seen it? Okay, send thumbs up if you guys have seen the problem and or done the problem. Oh, okay. So, well, bro, okay. I think, yeah, okay. Okay, so like let's just try like everyone. This is like not that hard problem. And after this one, we will do one like monster, like really big monster. And let's hope it won't take that much time. Uh, Rohit, I will give you one problem if you. Mm,
Yeah, I think Nishant also would use that problem.
Yeah, I've also done.
I
okay,
think we
sorry.
both did it together.
Yeah, we did do it together.
Oh, interesting. Let's wait. Okay, I hope you haven't tried this. Take a screenshot, right?
Yeah, I don't think I've done this. Yeah.
Yeah, take a screenshot.
Yeah,
Let's,
done.
yeah. Okay, so we will do this problem. It's not hard, but it's really interesting problem, to be honest. Okay, so what we given, like they all are positive reals. And then for every k we have this kind of equation, and we have to prove something like this. So what are like first intuition you guys get? And also everyone like give up your ideas. This is like not me speaking and telling.
Assume equality.
Yes, inequality. Yes, that's a good intuition. We will be using this. Like it's obvious like some kind of inequality is going to be used.
Okay, I mean, I I feel like induction will be like a big part here.
Yes,
We probably will have to induct on it.
yes. So induction.
If
So
all the terms are approximately equal, like if they're approximately equal, then maybe we can prove it's greater than equal to.
wait, what can be approximately equal? Acha, so you mean like if we add a n plus one, then we somehow have to prove some terms related to a n plus one or something
No,
like
I'm
that?
saying like if every term is like maybe it's greater than equal to 1, which would imply that all the terms are approximately equal.
Huh. Huh, okay. That's also that's a good idea. But the point is like maybe like you can have like A4, like A4 is so large, like A4 is equal to 2 or something. So like A5 can be 0, right? Because that just cancel out. But it's like, yeah, but this equation, but this equation should imply something further. So let's try to work on this. So this looks weird, but what can we do with this? Like obviously, like I don't think we like going to work on like this some weird type of expression, right?
We can shift the denominator since it's positive.
We can change the denominator. So you mean like we write it like this? No?
What if we try writing the denominator is like ek squared plus 1 plus 1 plus 1 dot dot dot. So we have k terms in the denominator, and like it is k upon ek squared plus 1 blah blah blah. So we could try to use some type of maybe AMGM or something like.
Okay. Also, like, so what are like first intuition is like, we're not going to like we maybe use somehow AMGM, but it will be somehow like terms will be go here and there. So like try to write down in that terms, like try to write all the expression you're getting. So your idea, it's better to write like this, right? Plus one, k
Yeah,
minus
this
one.
is what I thought.
Yeah. Okay. And that should be greater than AK plus one. Okay. Hmm. This is also interesting idea. If we apply AMGM, this just gives something like this is greater than 2 by k, like 8 to the power 2 by k. Interesting.
AMGM would be a bit weird. What wasn't there like something QM or something? Maybe
Okay,
that would help.
so QM tell us like, okay, I don't have space, I will write down. AMGM will be weird, okay. So QM will tell like this, right? So this all sums to k minus 1 again, which is also not that
Okay,
interesting.
never mind. This is worse.
Yes, but maybe it could work. Like I remember something like last to last year RMO problem was similar to
Yeah,
this.
there was like some P6 which
Yeah,
used.
P5 or something, I guess, which was like similar looking. But yeah, so what else you can do? We have AK square, right? But we also have AK here. And like we actually working kind of linearly. So we try to remove AK as much as you want. So let's rewrite this as this. This should be plus one, I guess. Yeah. Sure. Okay. Now, can you see something interesting? This is just equal to this, but now it's become more clear like what is happening. So here AK, you can write it like this. AK is greater than equal to K by AK plus 1 minus K minus 1 by AK. And this term is like these both are like somehow
Oh
related,
yeah,
right?
they are related. K plus 1 and we have K minus 1. K.
Yes. So, okay, we haven't done any step. We try to explore ideas, right? So we try to somehow apply AMGM, but which looks weird, more weird. And here what we did is we changed denominator, and then we send like AK to this side, which gives us this. Okay, Nikhil. So we get this. Now, where did you have guys seen this expression? Okay, there's another important point. In algebra, you always give labels. Like giving labels is so much. Uh, we interchange them, right? Like we change this side here and this side here, so we get this equation. Then we send AK to that side. So AK square become AK and AK minus one becomes. Okay. So one of the important thing in algebra is like give labels.
Okay, so k minus 1 by ak is just like bk or something.
Yes, yeah. Like, no, like k plus 1, because we have plus 1, right? So let this be bk. Actually, bk plus 1. I will tell you why. So what I'm saying, like, each, like, so many problems, you just see, like, you just get the idea because you give label. So if you get give label, you get bk plus 1 minus bk. Did I
Oh,
get?
and we sum and like they cancel out.
Yes, exactly. So now we sum like k minus 1. This will become bk minus 1. And you can just do it like so many times. So uh yeah, and this just become a1. Did you guys see? So and we just sum add all of them, and we get a1 plus a2 plus dot 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 ak equal to bk plus 1 minus b1. And do you guys know what is b1? b1 is like
Zero.
a1 0, so it's equal to 0. So basically what we get, uh this is like main expression in the question, k by k
Like
plus 1.
method of difference.
Yeah, method of difference. Basically telescoping. Not, I mean, yeah, this is basically telescoping sum, right? Because both of them are like just minus one term of another. So you just like uh, add all of the k's. Like, yeah, so basically we are add all of the k's. This is true for every k, and that's why we get this thing. So everyone clear till this, right? Uh, yeah,
Yeah.
everyone clear. Yeah, and Nikhil, I mean, we can interchange, right? Because all of them are positive reals. Like interchanging is basically like multiplying by same number, like reciprocal, and then do the things, right? Yes. Okay, so we get this equation.
But this doesn't seem like strong enough because like if we want to prove that k upon ak plus 1 is greater than k, like greater than equal to k, then we would have to prove that ak plus 1 is like less than equal to 1. But like if all of the
Yes,
ak's are less than equal to 1, then like how is the sum greater than k?
yes. So now we use like the thing like you said earlier, because like now we have general expression between n, right? So now we try to like this should work somehow. So we use induction. Like you always keep like induction back of your head. So now we're using induction. Like how? So first of all, see for what a1, a1 is greater than 1. This is just because I guess yeah, if you put, wait, not a1.
A2
Mm,
na n k n greater than equal
yeah,
to.
yeah, this should be greater than 2. Yeah. So a2, yeah. Okay, so, the base
Okay, it's
case,
just like a1 plus 1 upon a1. So
yeah,
that is
greater than
definitely
0, and this just imply by like if you see above expression, I guess it gets some, yeah, you can just see this, put k equal to 1 here, and you get like same expression. Basically you get a1, uh and like a1 is greater than equal to 0 because of amgm. This is true. Okay. Or we will work in like last. Now let's think induction. So suppose this is true for n, like till n, all of the numbers a1 plus an is greater than equal to n. Now what we do, we add n plus 1, right? Now so there are cases. So suppose case 1 is like an plus 1 is greater than equal to 1. But then we just get automatically like this sum is greater than equal to an plus 1 is greater than equal to n plus 1, which proves the induction hypothesis, right? Now, second case is like an plus 1 is less than 1, which is the main thing we have to use. But then we have this thing, right? So now like ak like this is like n basically now. So a1 plus an greater than equal to n by an plus 1. Now we know an plus 1 is less than 1. So this an will get like increase. So now what we have to prove? So see, like sometimes what we have, like if you want to prove A is greater than equal to B, sometimes you use like just like some C greater than equal to A less than equal to B, right? So similarly we doing here, like we want to prove like this thing. We want to prove an plus 1, this is greater than equal to n plus 1, but what we have this expression, right? So what does that imply? I'm just
Is
writing.
there something restricting an plus 1 for becoming infinitesimally small?
Not like this is like less than 1, so obviously this expression is greater than n now, if you, but we use like that very careful, like very interestingly. So see, if you add an plus 1 in both this expression, we get this, right? Everyone clear here? This equal to, we have to prove this.
Yeah, yeah.
Yes. No,
No,
oh,
we have to
sorry.
prove this. We have to
Yeah.
prove
So
greater than n plus 1.
yeah, what we have to prove is this is greater than equal to n plus 1. But okay, now okay, everyone clear here, right?
Yeah, okay, this makes sense.
Yes. Now we like express like this is reciprocal, but now you just have an plus 1 term. We know an plus 1 less than 1, and this is n and n plus 1. So let's just expand this out. And let's see what actually this is supposed to mean.
Okay, we can
Square.
get like a quadratic inequality in terms
Yeah.
of n plus 1.
Yes, exactly. So you get this, and this is just equal to, I'm writing, I don't know why I like this, square minus n plus 1, n plus 1 plus 1 then equals 0. And if you like this can be easily factor out like this. Yes, yeah. And this is true because an plus 1 is less than 0, less than 1. So this will become less than 0, this become less than 0. So both of them greater than 0. Right? So this imply this imply this, that imply this. And that's why the induction hypothesis comes.
Oh, okay, yeah, that makes sense.
So, okay, let me repeat. What we did, we tried to simplify the expression. This expression looks weird, but like that's the like understanding. Like all expressions are not weird. Like they're somehow going to use in the solution.
Yeah, we
We
have
try,
to like rewrite.
yeah, we rewrite. So we write like this, and then this looks induction. Like we give a label, or like if you have nice observation, you can just see this is induction. Like sorry, not induction, telescoping. And so you telescope, like you add from AK to AK minus 1, and you get this thing, right? And this just imply, yeah. Now you just write the redefine that, and you get this expression. This is the main expression used in all solutions. Then after this, you add AK plus 1, and you get this expression, right? Yes. Now, if AKA like an plus 1 is greater than 1, then if you assume by induction this is greater than n always already, then you already done. And now if you assume it's less than 1, then you just use the like fact, like, okay, is this greater than n plus 1? Then you simplify and you get this quadratic. You just prove, yes, that's true.
Can you explain the induction again?
Okay, induction is like you assume an plus 1 to a plus 1 to an plus 1 greater than n by hypothesis, and now we have to prove it for n plus 1. Basically, this plus an plus 1 equal to greater than equal to n plus 1, right? Now, if you add an plus 1 in both sides, and if an plus 1 is greater than 1, then it's already like greater than n plus 1, right? That just give the same thing.
Yeah.
And suppose
What
it's less
could be
than,
the
and suppose it's less than 1, then you get this simplified expression, and here you use the fact that an plus 1 is less than 1, right?
and how do you motivate induction? Yeah,
Okay,
yeah.
so induction is motivated because like see this, like this expression looks so much induction is, right? Like obviously you see like, oh, what if like all of them are greater than 1? basically what Tanishka said, like what if they are equally spaced? So it's really same thing. Like what if all of them are greater than 1? So then it just works. So what if one of them is less than 1? Then you have to use the expression, right? And then you can like assume the remaining thing on. And like if you know that like induction is like one best way to write the things. Like you do not have to solve everything from basic. You can just assume some first part and then add the remaining claim. So okay, so everyone understands. Okay, so now if everyone are here, I actually have another solution for both of these problems. But we also have like one more problem to do. This is like really hard problem, so I won't do it. Like this will take like at least 30 to 40 minutes. I wanted to do it, but we cannot do it. So let me see what can we do. Okay, how many of you can like stay for another what half an hour, or like anyone have to go? Then we will take one easy problem and
Yeah, I
finish
can.
this.
I can stay.
Yeah, I
Great.
can stay.
People. Okay, so only 2 people stay. Wow.
Yeah, I can tell.
Okay, okay. In the chat, like just thumbs up my hi message if you are staying. It will take like like it's so very beautiful problem, but it's really hard also. So otherwise we can
Source.
take source is A4, 2018 A4. Half of them. What is this exact half? Yeah. That will take a lot. Okay, let's do it. Like I will skip the calculations. Yes, that's my favorite part. I will left calculation for you guys. That's your fault, not mine. Okay, let's do. So I will just explain the ideas very nicely. So first of all, what does problem say? You have a0 equal to 0, a1 equal to 1, and an equal to an minus 1 till an minus k by k. And k can be anything. So like you can interchange the k. So like if you put k equal to 1, you get this equal to an minus 1. If you put like k equal to n itself, you get like this equal to n minus 1 till like a0 by n. Right? Yes. Now what we have to find the maximum value of a 2018 by a 2017. And obviously because of this expression, those numbers are doesn't really matter. But yeah, we'll find in that term only because the expressions are very nice. Okay, so what are the first idea? We have to
An
find
minus 2, n minus 1.
first should be like let's try some cases, right? Let's try to work on like what can be a2. So a2 can be like just a1 equal to 1, or it like two possibility only. A0 plus a1 by 2, which is like 1 by 2. And what is greater? A1 is greater. A1 1 by half is less. Okay, clear. If you see like if you just assume this everyone is 1, you can actually get like ai equal to 1, just like do like ai equal to ai minus 1 repeatedly, right? So you get 1 1 1 1 1. Yes, that's a nice observation. Ronit observed that this thing.
You
Okay,
can
now
get this inductively.
yes, you can get this inductively basically. So
Can't you prove this
suppose
by maximum? Because it looks like the average. Like the maximum of the average is less than the maximum. Always less than equal to the maximum.
yes,
And
yes.
hence There's one maximum. The maximum is 1 before that, so it's always less than equal to 1.
Yeah. That's also clear. Or you can just, yeah, that's also one way. Or you can just assume like, because all of them are like less than 1, you get, yeah, basically maximum argument. So basically n minus 1 till n minus k are less than equal to k. So 1 by k equal less than k equal to 1. And all
So
of
like
them
your
are,
difference is max 1.
yes. Wait, yeah, wait, how it 1? It's not 1. It's,
A 2018 minus A 2017 is maximum 1, the difference.
okay. Yeah. If you consider so much lower amount, yeah. That's really low amount. Okay, yeah. Like if you see, it's always greater than 0, right? So you cannot have like 2017
Oh
equal to
yes.
0.
Yeah, okay, it's less than 1,
It is less than 1, bit less than
upper
1.
bound.
Yes, and it will be really less than 1. But yeah. Okay. So now what are the ideas? Like smallest idea can be used like so much greater. Like, and if I just reveal one word, the problem is like kind of you get the ideas
Should
immediately.
look at
But I
like
want,
arithmetic mean, like because it looks like arithmetic an is
yes,
the arithmetic mean of the previous k terms.
yes, that's the intuition.
So
One more intuition I did was like I draw the diagram. So like this is like what x equal y equal to 1, and like the points are like this. Like either they can be this or something like this or something. They can go up down something like. And we want to find like maximum this thing for this what 2017 or 18 what. Okay, what? Okay, yeah. Okay, guys, you can just try a few cases. I just immediately. But I'm just asking you for ideas. So
Okay, one idea is that we should try to see like if an is 0, then what the okay, an can't be 0, so maximum can't be 1. We should
yeah,
see like okay, if also a 2018 also cannot be 1, so like the difference cannot be 1, right? Because
yeah.
if a 2018 is 1, then all before it is 1, right? So difference is 0.
maybe we want to make a 2017 the minimum of all the previous terms. Because
That
since a 2017 is the minimum, the average will be somewhere greater than the minimum,
Yeah.
and hence the greatest will get maximum.
yeah. Okay, yeah. I will come back to that. I will just explain the problem once again because someone asked. So we get like we have first two terms, and we have this equation like an equal to an minus 1 till an minus k by k, and k can be any number. Like we can choose it, and we want to find what can be the maximum value of this expression. And like if you put like k equal to 1, we get this value, and k equal to n, you get this value. This is 0. So like an can vary so much. And now we try to express what second what Nishant said, which was, yeah, we take a 2017 smallest, right? And then, but now what the question is like, if you try to take a 2017 smallest, 2018 will depend on last term, right? So do you want to take smallest, or you do want to take like second smallest and then it will become like greatest difference? That's not clear, but still like you're on right track. But it just we just have to somehow get like intuition what we heard. Like the like many kind of problems, like your idea sometimes doesn't work, or sometimes that's the exact idea. But you have to like kind of formalize or like make it clear.
What if we like let b 2017 equal a 2018 minus a 2017 and like define another series and find a recursion in b? Like that seems like an idea.
But what what do you mean by recursion? Like, oh, you mean like,
Yeah, bi in terms of bi minus 1, like that. So I think for that we will have to define like ki as a series. So like k1 is the k for a1 and like k2 is the k for a2, and that also we will have to define.
What if we actually use AM, GM, or RMS AM here?
So
uh,
considering the label idea, can we do like A2 minus A1 equal to B1, because we're actually what we care about is like the difference between two consecutive terms. We want to know how far apart they are, how far apart they can be. So
Yes.
like considering BI equal to whatever.
Yeah, okay. So if you consider like basically, yeah, B equal to BI minus 1. Now you have to find like maximum value of this thing, this expression.
Yeah.
Yeah. So let's just try to find for like some base cases probably like for B2, this is like what is this? So either B1 equal to B equal to 1 or like B1 A1 equal to 1 and this equal to 2. But that just imply like this is either 0 or minus 1. Minus 1 by 2. Discard like first two cases are always some weird. This can be 1 equal to A2 or A3 can equal to A2 plus A1 by 2. Now this is getting a little bit hard. But see, if both of them are 1, this is just become 1. And if one of them is 1 by half, then that just give us like 3 by 4, I guess. Yeah. Yeah, these are two cases. So B3 equal to A3 minus A2, which can be 0 by this thing, can be 0. This will be 1 minus 2, and this will be
A3 will have three values, right? Is equals to A2 plus A1 plus A naught by 2.
oh yeah, A naught also. Yeah.
By 3, by 3.
Yeah. Oh no.
By 3,
So
yeah.
many, so many cases I cannot do. Okay. 2 by 3. Then what is this? Same thing but 1 by 3. So 6. So 1 by 2 again. Like 3 by 6, which is 1 by 2. Yeah. I hope so. That's yeah. So, but yeah, if you compute this, you get like smallest value. Which one? What are we doing?
Do we
2. What?
want largest here? 2 by 3, right?
2 by 3. Why?
Oh no,
Wait.
2 by 3 minus the previous one, sorry.
Yeah, minus what we consider for 2 by 3? 1, right? But that also does not give. That gives us like minus.
Minus 1 by 3 or something.
Yes.
All 2, 3 minus a half, not 2 by 3. Oh.
No, wait, I'm somewhere
For
mistaken.
2 by
There's
3, we assumed A2 equal to 1, A1 equal to 1.
Ah, yes, yes.
4 minus 3. 5 is no. Wait,
When do you
did
get
I make? I guess like, yeah, but okay, guys, like you can guys do it.
when do we get
Wait,
B3 equal to half?
yeah, I guess basically B3 equal to half.
Well,
How
how do
do
we
we
get
get it?
3 equal to half?
Uh, this is true because like this thing. Like okay, let's just express them like this, I guess. Wait, forward this idea. One, this, if you consider this one, this can be one because of same thing. This can be one if you consider last two term, and this can be 2 by 3, right? Then second is like this is 1 by 2. If I'm not wrong, yes. And this can be 1 by 2, or this can be 2 by 4, 3 by 4. And wait, yes. And if you consider all three numbers,
1 by
it
2.
will be 1 by 2. Yes. And so we consider difference, which is like 0, 0, minus 1 by 3. 0, this one, 1 by 4, and 0. So 1 by 4 should be the, yeah.
Maybe 1 by n is the maximum. No, no, no.
That like, okay, what actually like say is like, okay, this is like just by induction, like this thing, like last k terms are less than 1, so last term k by k is less than 1, so you get a n. less than 1. Okay, now, okay, so let's, what I was saying, let's try to do this thing. Suppose you consider 1, 1, 1, 1, 1. Suppose you consider 2017 one terms, like 2016 and last one. So what will be this term, like at max? Like it will be either 1 if you consider any of these, because average is always 1, or it will be 2017 by 2018.
Yes.
But then difference is minus 2018. That's not good max, right? But because 0 is always greater. But there's an interesting fact. If you consider a problem in other way, like what can be least difference, then the answer is actually this. But we will get back to that. And I have to be more fast because yeah. Suppose you consider this thing. So till this you taking like last term only, and for this 2008 2017 you consider these all numbers. So they are 2017 numbers and 2016 are one. And now what can be 2018? It can be the last number, but difference becomes 0. So you won't take that. And what is like interesting to take is like
We should take like from 2016 over 2017 all the way till A2.
yeah,
We take everything till A1. A0 is 0.
yeah, A1, A1.
Okay.
This is A1, right? So
All right, that's
we take all numbers till A1. Why we not take 0? Because 0 will add nothing but increase the denominator, so which is not profitable. And if you compute this value, which I left for you, I mean it's not, it's like very less computation than what you were to do. Yes. And now my mouse is going up somewhere else. Okay. This difference is actually what? This thing minus this thing, which again you can compute, comes out to be 2016
Upon
by
2017 squared, I think.
Yes.
Yeah.
And this weird looking expression is the real answer.
But how do we just prove that this is the max?
No, yeah. It's we haven't proved anything. We just guessing this should be answer. Because like okay, you can ask like why you like saying this answer. It may be like okay, if you try to like change variable from 2016 or something, the upper expression kind of get somehow like lower or like upper. So okay, let me uh explain what is like main idea. So main idea is like suppose we what we trying to do, which is kind of not the main idea we have to look at. I want to change the perspective. So point is we have this expression. We are trying to maximize this thing, right? But the actually what questions want is like try to maximize an. So if you found some bound, like okay, we will name this like this thing, right? If you found this kind of bound, so this expression just become like what? 2018 minus m 2017, right? Like smallest 2017 is greatest. But
You
but
mean mn minus 1 is greater than or equal to an? You wrote mn is less than or equal to an is less than or equal to mn.
yes, m is capital, this small.
Oh, okay.
Yeah. Yeah, like generally consider this is like largest and this is smallest. Yes.
Okay, yeah.
So now this expression, I know like M 2017 depends on 2018, but now we will prove another very interesting fact. So someone tried to use what we call AMGM, but can you see like you cannot use AMGM here because all of them are like just linear terms. Wait, we will define later. I'm just like telling the intention. All of them are linear term, right? So if you see, you can express this term in terms of like previous terms linearly. Like coefficients are some integer or rational, and all of them are depend on previous terms like an minus 1 and so on. No, we never get square. And what is like if you want to maximize something, do you think like if you have like some interval, like this AI can take values from here to here, and AI is involved in some summation, right? Random summation. So if you consider this value, then if you just consider little bit less value, this can change little bit more. And if you either consider this extreme or this extreme point, then this value can reach, like this sum can reach extreme value, right? What I'm trying to say is like there's no profit to put AI middle, like mid of the interval. It has to be attain the extreme values. Like if a maximum is mi and a small mi, then AI has to be either mi or small mi. Or you can always like increase the AI for like summation, and then summation always increase. And if you want to find the maximum summation, that will attain when AI attain its maximum value. Okay, now let me just formalize this argument, like this intuition. So what we're going to do, suppose for an, we consider some function n, which is like what value of k we consider. So like if an equal to like an minus 1 till some an minus k, then like f of n equal to k, right? Now note like this f of n function change, like you can consider whatever k you want, but for now fix all of the a1 till an value and consider some ai fi. Now you just change this value, like just change this fi, whatever you want. But the point is like however you change, like now consider this 18 expression, right? This expression can be expressed as terms of like an and fi and some other terms. But if you some other terms are constant because all of the terms are defined and fi's are defined. Only thing we changing is, sorry, other fi's, fj's are defined. Only thing we changing is fi, which changes a of n. Do you guys understand? Like you consider like this summation in terms of all of the previous terms, and now we like we do not change any fi's like fj's except fi, and we can vary it whatever we want, right? And what we get is like this is linear system, like fi's is some term, this have some constant imply constants, and we add some constant, and this is the expression. And you can attain like highest value if fi takes highest things, like what do you call it? Extreme terms, basically. So this is like what I'm saying, like this expression is linear combination of previous terms. And for linear combination to be highest, you have to consider each of the extreme values of any of the things. And because of this argument, what I'm saying is an is AI, any AI should be either mi or small mi. Like if you just consider highest like highest or smallest number of AIs, you get the maximum expression, right? And what is mi? I forgot to mention. So mi is like maximum AI you can get from like this thing, like
That is one.
so like if you change like k from like 1 to n, what is like maximum for some k you will get maximum AI. That's the mi basically. So everyone understand this argument. Like you have to consider extreme value basically.
Capital MI is the one now.
Capital M and small m is like smallest minimum.
No, I'm
Or
saying
I
capital MI is one, right? For all AI.
this like, it's true if you consider from base. That's right. That's actually true. But if you we have to prove bound, right? We cannot just put the what are the capitals AI. So like what I'm saying, like if you consider previous term something else, but the first term should be like capital M can be something largest and smallest.
I get intuitively why you should have maximum terms. But like how do you prove it? Intuitively, this makes sense that you should take extreme case.
See, like the way to prove is like, see, what we formalize, we define like this fn function, right? Now we like what I'm saying basically, for except some AI, define all of the edges, right? And for that AI, you can change the k value. Others are fixed, and you can change the only that k value. And because
Okay.
of
If
that,
that AI value changes, so all the other AJ values will change. The AJ after AI.
you can like rewrite edges in terms of AI, right? You just rewrite everything
Okay.
by, and that will be linear combination, right? No, we never get quadratic. And now because you have everything in linear combination and you just changing one value, right? So that one value can like the maximum or any extreme value you can only get if you attain extreme value of corresponding things. Just give me a
Yes.
second. Yes. Wait, does everyone understand what we are just said?
Okay, yeah, I get it.
Yes.
Yes,
But
but your
we're assuming everything. Yeah.
Yeah. So now we will give one more claim. So what we were saying, like this claim is inspired by this thing. So if you remember, we get like smallest when we consider all of the sum, right? Like previous all sums, which is basically like n till like a0 by n, and we get maximum, which is like this, or like yeah this thing, which was like consider you do not consider 0, right? So which is like this thing, right? And what we indeed going to claim is like this is the minimum m. Okay, I should change the expression. Let the minimum m ln, and this is the maximum n for any n. This is another claim. And how you can come up with this is one way is to like look at the example, and it's kind of intuitive. Like either you consider all of the terms or you consider one except one terms. And we know like all of them are one at the like our solution. So that should be obvious. Second way is like you try to like I could have done it, but like it will take so much time. It's like you see like A3 take like either 1/2 or one value, I guess, right? And that just because you take last value and last two values, and you can do similar for a4. It will take last two values and like last three values, I mean last four and last two three, yeah. And that's why it's like it's something like this should come up. And also we change the labels, like suppose li is our minimum AI.
Also, if the maximum is not until A1, then that means that at some place some AI is less than 1. But if AI is less than 1, then you would have to include the AI minus k's before it to get the maximum. So like that's a proof why Mn should be the maximum.
Mm,
So assume An minus
like,
1.
I'm saying like this is just claim, like this not we haven't proved it. This can be proved, like okay, what we have to prove is basically this, right?
Okay, so like assume all the numbers from An minus 1 till A1 is not 1. Because if
Yeah,
it is, then this is true.
yeah. So basically, like even they are not one, maybe like for like we use one fact, but maybe like extreme values can they can attain some other extreme values in their corresponding,
Right.
and that
So
just it corresponding value.
right.
Yes.
So assume it's not all of them are not 1.
Hmm.
And that means that at some point it's some AI is not 1.
Hmm.
If AI is not 1, that means that none of the then that means none of the ones after AI can also be 1.
Yeah, they're not.
But then if you have all of that, You want to maximize it. So including the ones will help you either way.
Yes, yes.
Including the a minus. So is that kind of a proof?
No,
Why the
because like
maximum should work?
no, because if you consider like last 2018 and 2017, we actually go down to attain our maximum value, right? So while like doing the difference, the MN and MIs are actually not attending the one or like something less. And I told you less than also, right? So sometimes one is maximum MN only. We also have LN, right? And maybe they have to attend LN to get the extreme value at front. That's the thing. Like some of the AIs can be LI, like smallish, and some of the AJ can be MI. And so this expression can like lead us to like maximum things. But okay, so I will like not through this like all like both of the things, but this is like this you get by like kind of like not too much intuition, but see, what I said, like you have to attain MI, like AI's maximum value, right? Because they all are linear combination of each other. Now you try to explore what can be AI's maximum, and because of like our examples, intuition, like they like if you take all of the numbers, it should give something, and if you take like except like one, it should give like greater things, right? And this is actually true. Like this is just induction. So suppose this is true for n minus one, and AI can be equal to like AK, n minus k, sorry. I will just quickly go over this, but uh, I hope you will understand. We have to prove this thing, right? Uh, Wait, just give me a second. I'll just ask if anyone don't understand anything. I mean, if anyone do not understand something, ask me right now, because now on you will get more expression things, and I will just forward to answer the doubt. It's
We are
kind
going
of
to,
hard to follow, but yes,
so we are going to prove that last claim key, the A
yes,
naught, that AN
yes,
is less than the maximum value is attained like that by
yeah,
using induction.
induction. So basically, we assume this is true for n minus one.
Can we
This,
try the induction once by ourselves?
like see, there are two things. Either I can give you this as a homework. The induction idea is very, very, very nice. Like, it's hard to come up. I will just give you go through. Will that be
Okay,
fine? Like the
fine.
first idea, and you can work on the details.
Right.
Right. Okay, yeah. So yeah, again, let me explain what I did. We consider AI, and we can consider like maximum and minimum of AI. So how we do that is like consider AI as equal to like maybe AI minus 1 or AI minus 1 plus AI minus 2 by 2 or so on. Like you consider k value equal to 1 to n I. And now you consider the some k such that this AI is maximum out of all this expression. We call it MI. And some k so that AI is less than least. So we call it LI. And that's how you define M and LI. And like we don't have to define it, but and what we essentially claiming is this is Mi and this is Li. So like less than and greater than values are between this. Like for any k such k, this should be true, this expression, right? By induction. And you by induction you can like use the fact like uh some fact like this n minus 1 n minus 2 I guess is less than equal to a n minus 1. This is true by induction, and now you have to prove this, and you can try to do it like for any k. Yes, okay, this was the thing what we're going to prove claim, and how we arrive to this is basically because of this linear combination thing, which is like basically you just change one variable, and so other things change, so you have to attain the maximum value to attain max here. So anyone have, and does anyone understand something? If you do not understand something, ask me, right? And it's totally
Can
fine.
you
It's,
go back to that one thing? I forgot to write one. Sit down.
yes,
Yes, this one.
yeah. So everyone clear. What are the main idea we use? Like we use like because everything is linear combination of previous terms, we have to attend maximum value. And now the like because of try and error, basically you get like you kind of intuitionally tell like this should be maximum and minimum, and now you just prove it by induction. Now I will give you the sketch and you can work on it. Okay, yeah. uh Anyone have any question? No. Okay, yeah, you can ask me on chat also. Now we have to prove this. Now first thing we're going to do is because we have to use induction, we're going to take out the first term. And second, now we left it. Okay, so let me just for explain the idea. This should be n minus k by k, right? But if you notice, these are k minus 1 terms, right? So what is like best way to use induction? Like what is the way you can use this thing? This just tell us like ai minus 2 till like any an minus k by k minus 1, because yeah, the minus 1. This should be greater than this.
Change k with k minus 1?
Yes, exactly. And how you're going to change it is basically like this. K minus 1 by k into n minus 2. And this was the like kind of very interesting idea. Yes. Now you like this is the an expression, right? Now what we have, this is less than equal to, consider this expression. This is like an minus 1, right? Do you have?
Yes. Greater than or equal?
Yeah, so no, so this is like one of the an minus 1, the value an minus 1 can take. And
Yes.
because of induction hypothesis, we prove this should be like something like this. Okay. What we prove? Yeah, this should be 1 by n minus 1, n minus 2. Yeah, because of induction. This value is greater than this. Now, what we want actually, yeah, now we use another idea. Is like, what was it? Wait, let me just.
Wait, so now can you substitute k with n minus 2?
Yes,
Sorry,
basically.
n minus 1.
No, we don't know if it's because if k with n minus 1, then an minus 1 upon k decreases. So we don't know.
So,
But
for that,
by our induction hypothesis, k minus 1 is equal to n minus 2.
so for that, like for this idea, we do like this. This is very,
Yes. You substitute.
yes, and we like not substitute, like we use it again. So what happens is basically, yeah, so we have k minus 1 k here, and we also are going to remove this. So this is like same thing, but now we consider this expression because we like to work with this. And if I'm not, I hope I did not mistake. Just let me give this a, but I don't know. Yeah. Yes. Now what? Yeah. Now you try to simplify. So basically, if you simplify this, this just become 1 minus n minus 1 plus 1 or minus 1 minus 1 by k n minus 2. Okay. And this just remain the same expression. And now you just multiply this, you just take it outside and you basically get this thing. N minus 1, which is the expression n minus 1 in the denominator we want, then this, and then this minus with 2 plus an. First we multiply by this term, now we multiply by this, which is basically k into n minus 1 into n minus 2 times kn minus 1. Right? Now we again use this fact. Where is the fact? Yeah, this one. This. By induction hypothesis, this is greater than this. So basically, now look at this. This is an minus 2 till a1 and n minus 2. And so you do the same expression. If you look at this. Right. So now, wait, it was greater, right? Yeah. So now you get this is greater than n minus 2 till same expression plus n minus 1 by k. And this is minus an minus 1, same thing, and k n minus 1, n minus k minus 1. And now if you take like this thing common from both of them, and if you add the thing, this is minus sign, right? So it's equal to k n minus 1 minus n minus 1 minus 1 by, yeah, and this just become equal to k. Sorry, this is n minus 1 by, yeah. So this just equal to n minus 1. And now this you add with this, which tells you like plus an minus 1 by n minus 1. So basically we prove the argument like an is greater less than equal to this thing. And yeah, so the main interest like fascinating idea was like because you have to use induction, you change k to k minus 1 in denominator. And second, because you want to use induction, like same thing with n minus 1, you introduce this factor, these factors, and then you do some calculation. And now this works same for less than. Just you have to change rather than n, you will take n minus 1, you take n, and you play like the sign will play because of induction hypothesis again. So everyone get like this was a sketch, you can like work it on again by yourself. And this just basically proved us like yeah, so AI is lie between these two numbers. And basically AI has to take one of this value because of linear combination thing we told. Right? Now yes, I hope like if no one's saying something. If anyone have doubt, like please say. Now we have to prove like 2018 minus 2017, which is equal to, no, I mean, okay, which is what maximum greater than equal to m 2000. Like, let's just express it in maximum value. So what can be max 2018? 2017, 1 by 2017 minus 2017. Right? We take like maximum m 2018. And now if you like this is equal to this thing, wait,
You have to minimize A 2017 also, no?
yes, but let's like first let's look at this expression. So we have 2016 here, and like
But wait, A 2016 till A1 is like the maximum value of A 2017, I think.
this is like 2018 maximum value, right?
Correct, correct. But see, we have A 2016 plus dot 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 plus A1. We can convert that into the maximum value of A 2017.
This into
Yes, that part.
like adding 2017 or
So
yeah, yes,
multiply
yes,
by
yeah, yes, yes, exactly. That's what we're going to do. So we take like this term out, right? And you do this thing. 2016 minus 2017 again, right? And this is basically the maximum of 2017. And now you have to like take minimum of 2017 also.
and then you can just recursively go backwards, I
So
think.
yeah, so basically what I'm claiming, this is greater than equal to this. And now what we have to find is like what can be this value maximum, right? And sorry, this is like less than, sorry, I mean
L, huh?
L, yeah. And if you try to compute this thing in general terms of I, this become some few step of calculation. I will just go it 0 by n, and now you just subtract that. This just goes to
A
0.
naught is 0.
Yeah. This just become n minus
So x
1,
over n minus 1 plus x over n.
n minus 1, right?
Huh.
And see, all of the AIs are less than equal to 1. So this is actually less than equal to 1 by n.
Yes, and I think that is enough.
Yeah, and so that's just give us 2016 less than
From
1 by n.
2017 squared, yes.
Yeah.
So can you see like how like very like weird and
Weird and beautiful.
extreme problem, like you just consider every extreme point, like you consider this is also like maximum minimums are like not something weird AIs, they are just like either consider 1 or 0 because of its linear combination. You have to consider extreme values of AI, then you do the induction and there you use like some nice kind of factorizing trick, you can say, and then you do this calculation again. This is like another bound you have to use. So what I was intended, there were like two more solutions, and which are like bit different in itself. But I cannot cover it right now. But I will take like I will say like okay, anyone do not understand like did not understand any something like us right now. So we can.
I didn't
Do you want me to
understand that
repeat?
you were saying a lot of times about how the sequence being linear motivated the extremes.
Yeah, linear combination.
How does that make? I didn't understand how that makes sense.
Okay,
Why
so
linear and extreme?
basically see, so like as I said, suppose fix everything except one AI, right? And now you can like move the k terms of AI. Now if you try to split this value, this will comes up to be some terms times something like some function of AI plus some constant terms again. And this just will happen because like this all things are linear, right? Like what I mean by linear is like we don't have any square terms, and we don't yes. And yeah, and what happens here is like if this value can go till like li or mi, then this expression can like attach like reach its extreme value at like mi or li. It's not like maximum to maximum, we can have subtraction, but that's what basically it's saying. And yes, and okay, if you like, yeah, so do you understand this?
So
Yeah.
while we were bounding it by inequalities, we had to notice that we had to somehow get it to A 2016 till A1, A 2016 plus A 2015 plus dot 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 till A1.
Hmm.
Like after we get that, we can just use the fact that 111 is possible, and then we get
So
our
point is like we said we use extreme value, but we can use like less like least value also, right? Like we don't always have to use one. Like there can exist
yes.
some sequence where you use less value. So that's why we have to do like calculation in terms of like MILI and not one or something.
I'm saying ki, since we know that ki we have to reduce it at some point, and then just before the end we have to increase it.
Hmm.
So as motivation for that, we know that all the A 2016 and before that should be 1. So we want to bring our inequality in
But
terms of that.
yeah. If you think like for motivation, yes, that's kind of motivation you get. This get like by you like explore the problem so much, like this is very involved problem. It's not really easy. I come up with any idea or any bound I talked right now. Also about the linear thing or smoothing thing. Uh, if I wait, give me a second. If I remember, so okay, I will say like this is 2018 G naught, not G C. Yes. A sport. So go like you can go on AOPS. There's like this is like same kind of solution as like Yuan Chen. So you can like try to see there like like he said the same thing how the linear combination works. And if you don't understand like what are the labels I use, it's like same labels he used basically. It's like yeah. Uh,
Like,
yes. I guess yeah, you can go on AOPS and even on shortlist official solution, there are like two different type of solutions, and you can try to see them also. But yeah, so point was like this is like rather than something midway or some fancy stuff. This is like just you take extreme values of all the except of the problems, and then you somehow work it out. So that's the motive, like things I want to tell. And this is like beauty, some kind beauty kind of construction or introduction of new labels on numbers you should do. I hope you find this fun. Like was the time I see the question, it was really really nice. I felt yes. Okay, anyone have any question? Also, uh, I like now we don't have much time, but this question also have another solution. You can like go to see it. This is like 2015 A1, and I will take this question also have another solution. This is 2018 A2, and this solution is very like funny. So basically, what you do, which is like one of the ideas I also want to talk, is like once if you have some expression in terms of I, you also use I plus one. Like just put it in back of your mind, because now if you suppose you use I plus one, if I'm not wrong, we use I plus one, right? Give me a second. How is that going to do? Yes. Okay. So for like I plus 3, you get this expression. And for I, you get this expression. Right. Now, the key factor is like, because you have two expressions, and both of them involve like these two terms, right? Like AI and AI plus 1. Suppose you multiply this by AI plus 2. So basically consider this thing, I mean, plus 2, which will be equal to AI plus 2 square minus AI plus 2. And it's also equal to AI plus 3 AI minus AI, right? And these two expressions are equal to each other. And this just imply this thing, square minus AI minus AI plus 3. Or okay, I will just write same terms. That makes sense. Now, can you see anything interesting here? This expression. This is just I, right? And now what you do, you go over all the i's, like I equal to 1 to n. And now if you just add everything, and like suppose you yeah, now just you add everything, note like this will go through all of the AIs. Like at one point this will attain A1 to AN3 like AN, right? And similarly this thing also. So once you add all of them, this thing will cancel out. Then you will left with like summation of AI equal to summation of AI plus 3. Okay. And did you get this part? Like this will go through all of the AIs, this will go through all of the AIs as you go through all of the AIs. Then this will go through and again all of the AIs. So you just
Acha, so we
consider
can now bound it using Cauchy or something.
no, it is more simpler. Just multiply by 2. And because this go through all of the AIs, you can write this as in terms of
Sum of
matrix.
squares, okay.
Yes, sum of squares.
Yeah, like, okay, Cauchy also will give the same. Yeah, correct, correct.
Okay, okay. And this just imply like this sum, ai minus 3 is equal to 0.
Simple squares, sum of squares plus products.
It's sum, right? So yeah, so because sums are 0, all of the ai equal to ai plus 3. And that just like, that just imply the same all the claim. Like the
Yes.
period is 3, so the all everything
So
is.
3 must be identical. Correct.
You also have to prove like period cannot be 1 for this, and but yeah, that's easy thing.
That's the constant, right? So
Yeah.
constant is easy. What we
But
did.
this is like one like just you just use this fact and like you somehow just get like 2-line solution. And
This
another,
one's more beautiful, but the previous one was more satisfactory.
yeah. So previous one is like how you intuitively go, right? Like you go like, yeah, this should be happening this thing. This is like kind of like you have to know that okay, this term is seems common in both of them, so let's just multiply. And if you like come up with that idea, then yeah, just like finish in that term. And same thing happens here. I won't give time, but if you multiply this by this, like AK, and again you go with all of the case, then you get another some interesting expression and you use AMGM to finish, which is again like very interesting. So yeah, so all of these three problems are very interesting and so many different solution and ideas. So please like go over them after the lecture. Okay, so anyone have any doubt or anything to say?
Can you share the mirror after this?
Okay, yeah. Yes. Well, okay, I will stop the recording. Bye.